Is it engagement on the right, or I know the wedding ring's on the left, but they're both on the left then? You're probably right. It's been a long time. Okay, so this particular question was posted in the doc from the Math Excel. I do not need a calculator for this. Secant goes with which trig function? Cosine. So if the cosine of x, or if the secant of x is radical 2, what's the cosine of x? You could say 1 over radical 2. People on the street would probably say radical 2 over 2. That whole rationalization thing. Now, what was alarming to me on the test was the number of people who did not know that what I was asking for with a question like this was an angle measurement. These questions come up in a few different sections. So you could tell right there what kind of angle they're asking for, radian or degree. They're looking for a radian, right? Somewhere in the first quadrant. So I gave you the hint on the test to look at the unit circle. So is cosine an x value, a y value, or a slope? It's an x value. And you were told it was radical 2 over 2. Well, it's not 1/2. It must be the next one over, right? So it's either there or there. But they told me it had to be in quadrant 1 between 0 and pi over 2. So what's the angle? It's the one smack dab in the middle of the quadrant. Don't speak degree. Speak radian. Pi over 4, thank you very much. Okay. So, what's dumb? Oh. Yeah, there's like, this is do. The bad part is I can't use my writing tools on this particular Google Doc as easily. Anyway, do you notice that I took pi over 2 and I changed it to a decimal? So I changed it to 3, or if you take pi and divide by 2, you get 1.57. So they're telling me my answer has to be between 0 and 1.57. Now, because they chose that, I know it's radian mode. Got to have radian mode on my calculator, which is critical for me answering this question right. How do you get rid of tangent from both sides of this equation? What do you do to get rid of tangent? Don't tell me divide. What's the opposite of tangent? Not
tan to the negative.
Tangent inverse, right? So if you take the tangent inverse on that side, you would get x. And you take tangent inverse on the other side, you get 1.19 on your calculator. Is that between 0 and 1.57? Yes, it is. Therefore, that's the answer to my question. Now, did somebody else post this other question, which was very similar, down here? Anybody in the room post this question? Because it's basically the same thing. It's just 1.5 instead of 2.5. There were a couple other questions that came up last period. I should have recorded them, but I didn't. I don't know why I didn't. They asked this question. The graph of secant can be obtained by the horizontal shift of the graph of which of those? If you think back to, the blue one is the secant one. If you think back to, can you find any other graph that looks like it has all those parabolic shapes besides secant? Cotangent? No, it didn't. It kind of looked like an upside down tangent that's been slid over. The other one was cosecant. And so if you flip the cosecant over, it's going to look like the red one. Could you shift the red one so that it landed on the blue one? That's pretty much what they're getting at. The answer is yes, you could. You could shift it. and by a horizontal shift of that particular graph. They didn't even ask me how much. I believe it would be pi over 2, but okay, next. This particular question came up as well, and I think that I don't think I would ask this on a test, and here's why, because truthfully, it's a graphing calculator question. You can see that I took one side of the equation and made it y1, and I took the other side, -4 cosecant x. Look what I changed it into. I changed it into -4 times 1 over sine x. That's maybe a little step that we haven't done much with, but that's true. It's a reciprocal. Anyway, if you typed those in your calculator and then did the graph between -pi and pi, you could use your calculator to find or calculate the intersections. If you do not need this question to get to 80%, I'm okay with you skipping it. Okay? I mean, if you absolutely need it to get to 80%, okay. But if you, in fact, I should probably get rid of that one for next year. This one was a little different. It was cotangent. Here, let me see if I can zoom in a little bit more on that one. See if we can read it. Cotangent 1, or the cotangent of x equals 1. And we talked about in class last period how that would mean that the tangent of x would also be 1, because 1 is its own reciprocal. But they specifically said in this question that my answer had to be between pi and 3 pi over 2. That means on my circle, it has to be down in quadrant 3. So is tangent an x value, a y value, or a slope? Is tangent an x, a y, or a slope? Slope. That's why I drew the line right through there with a slope of 1, and I drew the angle measurement in blue right there, which is 5 pi over 4. Better. Does it make sense? Not make sense? So we knew the slope had to be 1. And they told me my answer had to be between pi and 3 pi over 2, so I knew it had to be down here. And so I knew it was this angle that I was looking for. And so I had to find this angle measurement down here in this quadrant. And it's one of the nice ones on our unit circle, because it's based on your 45-degree angle. So that's why your answer was 5 pi over 4, right? 1 pi over 4, 2, 3, 4, 5. Were there any other questions from the homework document that you wanted me to go over? Okay, so if the cotangent is -4/5, the tangent would be -5/4. They also, did they say something like my answer had to be, but what did it say it had to be between? Okay, 3 pi over 2 and 2 pi. Now, is this particular slope one of the common ones that we've talked about? No, it's not, right? So I'm definitely going to have to use a calculator for this. So I know that I'm going to have to do the tangent inverse of -5/4. The problem is, so I reach down, I grab my calculator, I know I have to be in radian mode. And the reason I know I have to be in radian mode is because they told me my answer had to be in radians. So as long as my calculator is in radian mode, I'm not going to mess it up. Tangent inverse, -5/4. So did you get something like -0.896? Now, 3 pi over 2. What is the decimal for 3 pi over 2? Anybody got the decimal there? Type that on your calculator. 3 pi divided by 2. What? 4.71. What about 2 pi? 6.28. Does this answer look like it's in between 4.71 and 6.28? I hope you say no. If you think about a unit circle, or I should say a circle, Negative 0.896, let's see, that is going to be somewhere about here. Right? Now, how you're saying, how did I know that? Well, negative pi over 2 is at the bottom, and I know that is a negative 1.57. So I estimated, folks, I estimated. So how do I use this thing to get an angle measurement which is between 4.71 and 6.28? What do you think? Yeah, you do. Okay, so let's call this 6.28. What are you going to do to get down to that angle measurement, which would give me the one that I'm looking for, which is this one right here? What would I do to the 6.28? Say it louder. Subtract, right? The 0.896, right? So I reach over to my handy dandy calculator, 6.28 minus 0.896. And they wanted, I think, to the hundredths place. So 5.38 was your answer. Question? What? I don't see why it would unless it's a rounding issue. Let me do that. Maybe I need to use a more accurate version of pi. Minus tangent inverse of negative 5 over 4. Oh. 2 pi plus tangent inverse negative 5. Yes, this was rounded, so 5.39. It should be accurate if we go. Yeah, it was just a rounding issue. The rounding issue came in the fact that we rounded both of these things. So I was gonna say that should be right. Whoops. All right, good. All right, do we have another one? Anything in the homework that or did anybody post another one in there for me? Don't go that way. Come on, stop it. Go down. Did anybody post anything else in here? Besides that one, which... Still don't know where the document is? Okay. Okay, example 4 from our notes is describing end behavior of a tangent inverse function. Now, we talked about tangent inverse function in the previous part of the videos. And we know that it goes from, it's got these horizontal asymptotes at negative pi over 2 and positive pi over 2. And because of the restriction done on tangent, we get one of these kind of things. Obviously not crossing the asymptote. So what is the limit as x goes to infinity of tangent inverse? What's going on when you go far to the right? What's it getting closer and closer and closer and closer to? Pi over 2. What about the other side? The limit as x goes to negative infinity of tangent inverse. What do you got? Negative pi over 2. So they're not really that difficult. Remember, limits are the y values only. But that just helps remind us. Now, can you find limits on sine inverse and cosine inverse? Well, it wouldn't make any sense to talk about those. Why wouldn't it make sense to talk about end behavior? Yeah, they stop, don't they? I mean, we drew little pictures of those, and they were things like, that sine inverse, was doing something like this, and cosine inverse was doing something like this. It doesn't make sense to talk about infinity and negative infinity on those graphs.